Well, partly the reason why I ended up in molecular biology is that I had a family that was full of scientists and a few doctors, but most particularly my maternal grandfather he was a scientist, and he was very helpful, and he really taught me chemistry and gave me a lot of interest in scientific things. So we'd be walking down the street and he'd just say, well, what do you think that is in the tree, or what's this in the ground? And he made science very interesting, but also he made it accessible, because he could often explain a lot more than somebody from within the school, or from a text, from the information you get from a textbook. Specifically from my research, well, these days, of course, you have to be very focused on your research, and my current grants are firstly on cancer. So I think most people know that with cancer, we want to be able to cure it, or to prevent it. So my grant at the moment is to do with finding new ways of detecting neuroendocrine and pancreatic cancers, and also ways of potentially treating them, working with an oncologist. Oh, absolutely, because all research is contemporary, and by contemporary I mean it applies to real world conditions right at this very moment. These days you don't get any funding unless you're working on something that's related to the present and that has application to the future. So it is contemporary. I think the most exciting discovery I made was when I was working with a breast cancer cell line and discovered that you could convert it, you could switch it on from being cancerous to non-cancerous. And at the time, there were no other models of how you could do this. If you had a cell line obtained from a patient with cancer, then that cell line stayed the same. But what my cell line did was that you could switch it on using various drugs. You could get it to become more cancerous or less cancerous. And that was very exciting. It's actually been patented now. Well, challenges. Let me think. Probably the greatest challenge for all researchers is getting the funding to do the research. It is very competitive today, and the government grants are the ones that everyone aspires to, or most people, like NHMRC, National Health and Medical Research Council, or the Australian Research Council. We all try and get those grants. I've had quite a few of those, and so that's been a challenge to do that. Another thing, as an academic, it's quite challenging to encompass the three pillars of academia, which is teaching, research, and service. They're quite different components. And to be successful, I think you have to be good at all of those three. And that can be quite good, because they're quite hard, because they're quite different from each other. The most important skills you need are, first of all, to be enthusiastic and energetic and interested. Those are by far the most important factors to drive a scientist. Because as a scientist, you're continually trying to solve problems, and if you're not interested in the problem and interested in finding a solution, then it won't work out. I think scientists are always attracted to problems, and they love solving problems. In fact, they're always looking for problems. And in science, you have so many questions to answer, that you're continually problem solving from day to day. Well, a research scientist has got to be enthusiastic and energetic and persistent. So they have to be enthusiastic to sustain their approach to the scientific problem that they're solving, because that's what drives you. I suppose the curiosity about the problem, about what you're researching, about trying to find out the answer to the question, whether it's anything to do with treatment or cure for cancer, or looking at corrosion in marine environments. Those are all things that a scientist, when they study, will be very curious about. And so that's what drives the scientist. Well, science has been a really major feature, a large feature in my life. It's been something that I took up when I was sort of professionally when I did my PhD, but it's been an incredibly important part of my life, and it's overflowed into my family as well, because I've got two children who are engineers and one other one who's a scientist. So I think enthusiastic approaches to science is what's driven me, and it's helped the family as well. I never find my work boring, ever, because science can't be boring because it's so unpredictable. All the time you're thinking a process works in one way and you find that that's wrong. You do some experiments, you find that that's not how it works. It's a completely different mechanism, and it gives you quite a buzz when you find out that your idea about something was wrong. And sometimes you find out something that's wrong and everyone thinks a known pathway is what's actually happening, but then you can have a few discoveries that will show that this is not the way it should have been interpreted, and really the pathway works in quite a different way. But scientists are never afraid of going back on their conclusions, because it happens all the time. For science to advance, it has to collect the data, then you have to analyse that data, and then on the basis of that you come up with a hypothesis. Then you might test it and come to a decision about what you think is happening, or interpret it, but sometimes your interpretation is incorrect. And then when you get new data, then you have to interpret it in a different way. And this happens all the time, but scientists never mind if they have to go back and say, well, as it turns out that, we know that this pathway is not working through this GTP, it's working through an ATP system or something like that. Well, I don't really think I wish I could have told myself anything, because I don't feel it's terribly productive to look back on your life or anyone's life and say, if I'd known at that stage, I would have done this, that and the other, because the fact is at that particular time, you have a certain amount of experience and knowledge, and you made the best decision you could based on that. And, there's no way that you could have known what you know today. So it's pretty fruitless, I think, sort of saying that. So I always think that no matter what you do, you probably made the decision based on the information you had and the experience you had. And it may prove to be, not a good decision at the time, but that's what happened. So it's really better not to think about those things. Well, a scientist comes to work, and inevitably the first thing is that things have to be fixed. Things haven't quite worked out. The freeze dryer's broken down, the fridge is leaking, somebody's used all the antibody and we need more antibody to do the experiments. Then we need to find a desk for somebody. Very trivial things, but very important. There are so many little problems. In fact, the whole day of a scientist is pretty well problem solving. And a lot of it is fairly trivial, I suppose, like anyone. Well, like anyone's job, you're just dealing with small things. But then occasionally, of course, you have the bigger questions and the bigger decisions you have to make about the science, the actual science that you're doing and the direction that it'll be taking. But it's pretty well unpredictable. And if you can get some time to read a manuscript or even write one, well, that's very good going. But a lot of the time is spent in troubleshooting. Well, when I'm talking with people about their careers, I just think it's so important that you decide to embark on a career for the interest in it, not for other reasons like financial reasons. And when I did science, I did it because I loved it. I thought it was very interesting. I had a family background in science, but I found science was fascinating, and my grandfather gave me electronic kits and scientific experiments to do, and it just seemed automatic that I would do science. So I would advise students like that to pursue science and not think too hard about what happens at the other end, because I never thought at all about it. I know today people have to think about their career and their money, and they're a bit more risk averse. So they're less inclined perhaps to follow what they like rather than to do what they think they should do. But since you're going to be spending such a long proportion of your time at work, surely it's worth working in a job that you like. And so I think if somebody of 15 years of age is interested in science, they should do it, and there'll be lots of openings coming up. And I never planned to be an academic. I never planned to be a professor, ever. I never even thought about it. I came upon my career accidentally, and this is what I often find with my students, that they are progressing along and they find an interest in some aspect and they pursue that, and that leads them to a whole new opening. I think that's a really important thing, that you can't know what all the doors are in the future. You just have to head for the ones that you think look interesting, and something will open for sure.